All right, so just to reiterate, 12 ounces of chips go with 48 cookies, just like X ounces of chips go with 285 cookies. So we can cross multiply. And then what's our next step? Dividing. Divide by 48. So this answer is going to come out probably not perfectly. I'm going to take the answer and I'm going to divide that by 48. So 71.25. Okay, now here's the thing. You're probably not going to measure it down to the nearest quarter ounce. You probably wouldn't even measure, you'd probably go by bags, like how many bags of chips. But let's just say for the sake of argument, you have a kitchen scale, okay, and you put the chips in the bowl or whatever and you measure them out. So to get it as accurate as possible, I would need 71, so about 71 ounces. Yeah, so I can say the word about, or you can do a squiggly equals, however you want to do that, but about 71 ounces. Okay, now if you had to do something like number of eggs to the recipe, you would have to basically round up on the number of eggs because you can't do a part of an egg, that's just too much work. So sometimes recipes have a little bit of a leeway in it, but this is how you would figure out if you have a goal amount. So you would make that work out and you can find out how much you need to make that. So this 285 cookies is kind of a strange amount of cookies, but all right. Now, what I need to do then is I need to bring up the other thing, because what we're working on today is how this whole idea works with, yeah. Oh, okay. So now here's the thing. We're going to work out the same idea with some triangles because they are also proportional. Notice we have a triangle on the left and we have a triangle on the right. So what we're doing today is we're mixing in a little bit of this, but it's still proportional. I have this little symbol here. It means is similar to. Okay. And I have a couple of little notes on your page there. Okay. So I can just talk about them. This little symbol means is proportional to. It does not mean that they're the exact same figure. Okay. They're the exact same shape, but they're different sizes. So what that means is that every angle in here is the same as every angle. It just got blown up. Okay. In a scale model, that's what happens, is it's exactly the same, but it's a different size. The sides are not equal though, but the sides are related to each other. The sides are what we call proportional. Okay? Just like we were just doing on that problem, the sides are proportional. So if you're trying to do something like find X and find Y, which will be our directions, find X and Y, you're going to have to do that as two separate problems, two separate ratios. So on a problem like this, you have to identify the parts that go together that both have numbers in the two different triangles. So 8 is on the same side of the triangle, okay, because they're the same triangle, it's just this one's a little bigger. Which one is in the same position on this triangle? The 12, the 14, or the 16? Somebody don't say it out, but somebody, actually I would like your opinion on that. So we're going to do the 1, 2, 3 thing. Okay, it's either 12 or it's 14 or it's 16. Put up one finger if you think it's 12, 2 fingers if you think it's 14, 3 fingers if you think it's 16. Which one is in the same location in the other triangle? Okay. Everybody give an opinion, please, even if you're doing it on the slide so that you don't have to show everybody what you think. There's a couple people who have not given an opinion. Okay. It is definitely not 5. Okay.
No, 3 minus 1.
Okay. All right, thank you for all of your opinions. All right. All right, so anyway, we have this. If we notice the triangle, it looks exactly the same, but the 12 is in the same location. Okay, this triangle got blown up. AB and GH, AB and GH in similar triangles, the letters go with it too. So if you want to know the one that goes with AB, the letters are in the right order so they match up as well. So 8 and 12 go with each other. I can make a ratio out of 8 and 12. So 8 is from the left triangle and 12 is from the right triangle. Not right triangle as in 90 degrees, but the one on the right. That's going to equal a ratio from the other side. Now I can't find X and Y at the same time, but I need to pick something from the left triangle and pick the one that's in the same location on the right triangle. Okay, so pick either X and Y from the left triangle. You can't be wrong because as long as you pick X or you pick Y, Rio, just pick one. Which one do you want to pick, X or Y? Y. You want to pick X? All right. So out of 12 or 14 or 16, what's in the same position as the X? Okay, I want to see everybody give me an opinion, 1, 2, or 3. Okay, okay. Okay, congratulations. You all need to go to the bathroom at the same time. Okay, good. Number 3. Here we go. So X is on the left and 16 is on the right triangle. So I have a proportion that I can solve. We can cross multiply just like you cross multiplied before. So let's do that. And some of you might be thinking, why don't we reduce first? Well, we don't reduce first because I'm trying to teach this skill right now. You could reduce if you wanted to. So 8 times 16, 128 equals 12x. So x equals, how do we find it? Divide by 12. And that gives us, oh no, 10.6 repeating.
What's the 7? What's the 7? There's a 7.
Okay, so
That's because that's
we're not gonna do rounded on this. Okay, but we know that it's 10 and something. All right. So here's what you can do. I have 128 and it's divided by 12. We know it's 10. Okay, how much is 10 times 12? 120. So you can do this all in one step if you're using the calculator to get the whole number part. And then this leaves me 8 is my 8 remainder over divisor, 8 over 12. So I want to reduce 8/12. Many of you know that you do what to numerator and denominator? Divide by 4. And that gives you 2/3. Okay, 10 and 2/3. 0.6 repeating is also a pretty common one. So if you start seeing that on your calculator, that is always going to be 2/3. So 10 and 2/3 is your exact answer for that problem. Okay. Let's look at the other one. Okay. We're going to use this same 8 over 12 again. We're going to use the same 8 over 12. I have the left triangle over the right triangle. But now I need to find the other variable. I need to find out how much y equals. So for that problem, which one, y comes from the left triangle, which is the corresponding side, which is the one that goes with it that's on the right triangle? Option 1, 2, or 3. Everybody show me. Option 1, 2, or 3. Everybody chime in with showing me with your fingers. 1, 2, or 3. I still have about 2 of you that aren't really participating in that. Because, okay, thank you. All right. Okay. What's your 2? Okay, so it's number 2. It's 14. 14 is in the same spot as the y. So y over 14, you can cross multiply to find that one. Okay, so 8 times 14.
72. Oh, wait.
112 equals 12y. Once again, when we divide by 12, it's not going to come out even. Okay, so we're going to do 112 divided by 12. 9.3 repeating. Wait a minute. 0.3 repeating. What fraction is that?
3 over 9.
1/3. Okay, remember I said 0.3 repeating comes up often?
3 over 9.
9 and 1/3. Okay, so how do I know it's 9 and 1/3? From what I told you, 0.3 repeating comes up often, so you should tuck that away in your mind. If you don't remember it, 112 divided by 12 is 9 and something. 112 divided by 12, you know that it's 9 and something. Oops, sorry. I want the 12 out here. Yeah. Okay, I want to show you. I want to finish explaining, and then I'll come and see if you don't understand it. So we know it's 9 and something. 9 times that is 108. That leaves 4. So 4 over 12 reduces down to 1 over 3. Okay, now what? Okay, so you got it in fraction form, but it's a improper fraction, which, okay, yeah, if you have it as an improper fraction, you can change it into a mixed number over that, that's fine. But just, especially in problems like this, it's better to have it as the mixed number than it is as the decimal. All right, so there's that one. So, yes.
Wait, why do you always start with 8 over 12 and then equals
I'm sorry?
why do you start with 8 over 12 and then you'd be
Because the sides of similar triangles are proportional. So if they're proportional, that means that the ratios have to equal each other. You have to start with some known numbers so that you have only one variable to solve for, because you can't have more than one. So you pick the side of the triangle that has both of them have a number in it. So you're comparing one triangle to the other triangle. So I chose 8 and 12 because they were both in the corresponding sides, the sides that go together. Because notice that AB and GH are in the same position on the triangle. And that's what you have to do to make that work. We have another example there, so we can start from scratch on this one. Okay. Notice the notation here, triangle LMN, triangle FDE are similar. So that means that our sides are going to be proportional. Once again, we're going to compare our triangle over here, the triangle on the left, to the triangle on the right. Okay, so here's the thing. We need to figure out what sides both have numbers on them in the same position. Eli, what do you see?
5 and 8.
Good. The 5 goes with the 8. So your first step is going to be identify which sides in the triangle are on the same place in the triangle that both have numbers in them. So I'm comparing 5 goes with 8, like. So somebody give me the other fraction or another fraction. 7 and B go together, so what goes on the numerator, what goes in the denominator? And good, because you're going left to right. So notice that in this case, the variable goes in the denominator. Okay, it doesn't have to always go in the numerator, it can go in the denominator. So I can cross multiply, and I can do 5b equals 56. This one's kind of easier to just go ahead and divide out. 56 divided by 5. So 1, 0, 1. All right, pardon my sideways writing. And 1/5. So 11 and 1/5 is B. Now on this one, if you put it in the calculator, it would say 11.2. If the fraction ends, you can just go ahead and leave it like that. All right, Caleb, can you tell me how to set up for the other side?
10 goes into on the right side?
Yeah, so 5 goes with 8, like what over what?
10 over A.
Good, 10 over A. So we're going to cross multiply here.
5A.
5A equals
80.
80. Somebody, I know you got all of you got your calculators in front of you, even if they're simple calculators. So what is my answer here on this one? Abby?
A equals 16.
A equals 16. So no reducing there. That one's just there. Just divided by 5. Okay, so pressure off as far as the calculations on this chapter. Okay, so little bit of, and these, spending our time on really understanding the ratios will help you, even if you're going to be like a nurse or something, or a doctor. You need to know your proportions so you're giving people the right application. All right, so if you have a scale model, it's going to compare something that's going to be on a map or a model compared to what's happening in reality. So a scale of 1 inch to 10 miles means that for every 1 inch on the map, it's going to be 10 miles in reality. So you need to fill in on your paper. If I have a scale of 1 centimeter to 15 kilometers, it means what on the map is actually what in reality. I'm going to see, Jillian, do you know what will go in these blanks? Okay, for the original one, it's inches and miles, but look at this one. Which one will this be? Good, so 1 centimeter goes with, good, kilometers. How many kilometers? 15 kilometers. So if you had these worked out, 1 centimeter goes with 15 kilometers. So we can use this to make, to figure out on our maps what's happening. So here's some information. A map in New Jersey has a scale of 1 inch means 10 miles. So our map versus the real. So I'm going to make my proportion the map versus the real. So I have 1 inch represents 10 miles. If Trenton and Camden are 2.8 inches apart on the map, so where does the 2.8 go?
On the top.
In the numerator, 2.8, because on the map, it's 2.8. And in the denominator, we get how far apart, which would be our variable in reality. So this actually, when you have a scale given, it's pretty easy because you're just, when you cross multiply, you're always going to be multiplying something by 1. Caleb, you with me? Mm-hmm. So cross multiplying, this gives us 1x equals 10 times 2.8, which is 28. But what's my unit on that? 28 what? 28 miles. Because we're looking at the reality side of it. Okay, this is our map in inches. This is our real in miles. So since the X is in the real spot, that makes it 28 miles is our real answer. Okay, so this one, the scale factors are kind of pretty neat because they're give a nice answer. Let's go over here where I have my next one. Two cities are really 90 miles apart, but are 4.5 centimeters apart on a map. We want to determine, we want to find the scale. Don't do that.
You skipped one.
I skipped one?
I think so, wait. No, never mind.
Do you-
Never mind.
Nope, didn't skip one? Okay, thank you.
Never mind.
Two cities are really 90 miles apart, but are 4.5 centimeters apart on a map. Determine the scale. So the scale is comparing what to what?
Inches to miles, not
So-
all inches to miles.
So the map or the model compared to what's really happening. So I want the map versus reality, and I don't want to, I'm not making a proportion this time, I'm just making a fraction. So what goes into the numerator? What do we think goes into the numerator? What's the map number, Brielle? 4.5 centimeters, good. And so what would be the reality, Brielle? 90 miles. Okay, so what I want to do is I want to make this into a fraction, but I want to reduce it. Isn't it what? Well, it needs to be, we need to get rid of our decimal. So there's a couple of different ways that we can handle this. Okay, if we want to get rid of that decimal. We can allow our calculator to do that if we want to get a reduced fraction. Or we can multiply this up, or we can divide it out and then change that fraction. There's a few different ways we can handle it. Let's use your fancy calculator first. This one's fun, okay? Look here. If I do 4.5 divided by 90, I get 0.05. That's not a fraction, but here's a handy dandy little trick. If you want to make it into a fraction, there's a button that's called math. And here it says fraction. So if I do that, it's going to turn my answer into a fraction when I hit enter, and I get 1 out of 20.
Wait, what?
All right.
Wait, what?
What had happened was 4.5 divided by 90.
Yeah.
And then there's a button on your calculator, math, and the first thing that it tells you is you can turn that into a fraction, and you get 1 out of 20. So 1 centimeter is 90 miles. 1 centimeter is 20 miles. All right, so now those of you that need to do this by hand, okay, 4.5 centimeters divided by 90. All right, you could divide that out and you get your 0.05, okay, but you want to make it into a fraction. That is 5/10. Divide numerator and the denominator by 5, and that's 1/20th. So there's your 1/20th again. To write it as a scale, you would write it with the 2 dots like this. So there would be your scale factor. Yes.
Can you go back to last problem like really fast?
Everybody have this one written down first, though?
Yeah.
Oh,
Okay, I gotta hold on.
Syntax. Syntax error.
If you must. Okay, good?
Okay.
Okay, and now back to the other one, which was down. This one.
Thank you. I'm good.
Okay. All right. If we get through only one on this, it's still okay, because we needed to spend time on one that could be problem. Because these are basically the same problem asked in different ways. Okay, so the scale drawing, this should be drawing. So fix that. The scale drawing of a rectangular field is 4 inches wide and 9.5 inches long. Okay, well, you know what? I'm going to actually draw my rectangle so I can see it. Okay, so our scale drawing
Be like after the
is,
size.
no, I didn't measure a thing there. I'm just gonna make a rectangle so that I can see it. Okay, it's drawn to a scale of 1 inch, so this is in inches, or 4 inches. So it's drawn to a scale of 1 inch, goes with 300 feet. So we need to find on our new one, okay, we need to find out how much it is really, okay? So we need to find the 9.5 part, we need to find the 4. Our scale is that 1 inch turns into 30 feet. So we have to do them in 2 separate parts. We're gonna have to find the length of the field for real, so here's my length. So how would I set up for finding the length?
9.5 over X.
Okay, so 9.5 over your variable, 9.5 over our length or our width. So we can cross multiply. 1L equals 9.5 times 30. So 185. So that tells me that the length of this field is 285 feet. So the real one would be 285 feet. And our width here, how would I set up that proportion? We still have to deal with the 1 inch and 30 feet. Eli?
So like 1 over 30
Equals
4 inches
4 inches from the mat
over W.
over W. So once again, 1 times W is W. 30 times 4 is, that one's easier, 120. So our width is 120, what? Feet. Because this is the real part. You've got this, you've got the model and you've got the real, and then I've actually made a model of the real. So anyway, on the picture, because you've got, I'm just trying to make you see it in your mind. So the dimensions of the field is 285 feet wide, or 120 feet wide, and 285 feet long. So when you have 2 dimensions, you have to set up 2 proportions, kind of like we did with the triangle problem. Now the last one is exactly the same logic, but instead of that, you have a blown up picture. Well, kind of the same logic. The scale is 1 to 6. We don't even have units on that. But we need to deal with the width. Okay, so it starts at 3 inches wide, and we're trying to make it go to our unknown width. So we can cross multiply. So W equals 18. So 18 inches. And our length, 1 goes with 6. That's our scale. 5 inches goes with our new length. That's a cursive L. So L equals 30. So 30 inches. So our new picture, once you blow it up, the enlargement will be 8 inches by 30 inches. So whenever you're trying to find two parts in one of these problems, you have to go with the whole and 2 problems out of it. That should be it. So tonight's homework is the proportions from yesterday's lesson, plus the cookie problem and the other problem that we did at the beginning of class. This one goes with assignment number 21. I gave you I gave you slightly less problems as far as the number of problems so that we can do 21 and 22 to do Monday. Okay. All right. Bye. Have a great day.